Hey everyone. So, welcome to another video in my series for the Blind 75 LeetCode problems. Last time we did the valid palindrome problem, which involved strings and two-pointer approach. Today we'll be going over the valid parentheses problem, which is also a string problem, but it's going to be using a different kind of data structure called a stack. So first, let's go ahead and read this problem. Given a string S containing just the characters, so the parentheses, open and close, the open and close curly braces, and the open and close brackets. So given a string containing just any of these characters, determine if the input string is valid. And we define an input string to be valid if open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. So, for example, if we have a string right here with the open and close right here, this should be true because we have one open parenthesis and then a corresponding closing one. In the second example, we have one of each, one opening and one closing for each of these, so that would also be true. But this one would not be true. This would output false. So you can see we have a opening parenthesis, but we don't have a corresponding closing one. And then likewise, we have a closing bracket, but we don't have an opening bracket. So this would be false. And as this problem said, they should also be in the same order, so the closing should come after the opening. Otherwise, it's not right, even if it does have both. So yes, these are our constraints, and it's only going to contain these characters. Okay, so let's go ahead and do a Java solution. And actually first, let me go ahead and show you guys the stack, because that is the data structure that we can use for this problem. Let me go ahead and open this up as well, just in case. Okay, so the stack utilizes a LIFO kind of architecture, which is last in, first out for objects. So we have the push and pop operations for this, or methods for this data structure, and then a peek as well to see what the top item is, as well as a method for seeing if it's empty, and then we can also search and see how far an item is from the top. And so stack is, let me actually go and see if there's a whiteboard that I can get. Okay, so a stack would look something like this, and then actually, sorry, let me do this. 0, 1, 2, 3, 4. Okay, so stack would go like this. It goes from top to bottom. And it's a LIFO, so last in is the first one out. So let's say we wanted to enter these objects in this order onto the stack. So we would first do 0, which goes at the very bottom. And then we can push 1 onto the stack. And then 2, 3, and then 4. So it always goes all the way down to the most recent available one. You can't just start from the top and then go down. It doesn't go that way. It starts from the bottom. And now you're only able to have direct access to the top of the stack, the very top element of the stack at a time. And so if we want to get rid of one of these elements, you have to start from the top. And so if we want to get rid of this 4, then we can pop it off. And let me see. Let's just erase this. Okay, so that we can pop that off, and then we can move on to the next one. Why is this not working? No, not that. Let me just try refreshing this. Seems to be a little bit finicky. Okay, wait, 0, 1, 2, 3. Okay, so you can see we popped off that 4, and now we can pop off the 3, and then the 2, and then the 1, and then the 0, and then we would have an empty stack. And you can see how this shows a LIFO structure, since 4 was the last one that we put into the stack, and then it is the first one that then comes out. Okay, so let's see here. And when a stack is first created, it contains no items. Okay, and we'll also go over what the array DQ is. So let's see here. Am I missing anything? Stack. So just a bunch of implementations. Okay. And these are a bunch of methods that we could use. Okay, so now that you know how the stack works, we can go ahead and get started here. So first, we need to take care of 3 edge cases in this solution. The first case is opening and closing parentheses count as equals but are mismatched. Second is opening bracket count is not the same as the closing bracket count, so it's either greater than or it's less than, which those are both count as 2 different cases. So those are 3 edge cases that we should take care of here. So let's go ahead and start with creating our stack. We're going to create it with character objects. We're going to be putting characters onto our stack. That's what we're going to be filling it with, rather. Okay, now let's go ahead and do a char array. And yes, we can convert this given string into a char array. And so now we have an array of all the characters of the string. Now let's go ahead and loop through those. Now we want to do a couple checks right here. We're basically just going to be checking if character here that we're currently on is an opening character. So that's either this or this or this. Oops, wrong one. Just this. Yeah, there we go. So we're checking if our character that we're currently on is one of the opening symbols. And if it is, then we can just push that onto our stack. Okay, then we can do an else. And this is taking care of that third case that we were talking about, where the opening bracket count is less than the closing bracket count. So first let's check if the stack is empty right here. And if so, then we can just return false right here. And that would be because, so basically if we're checking if we have an opening character right here, and if we don't, then that would mean that we have a closing character. And so if the stack is empty, then that means there is no opening character, corresponding opening character, for that closing character, which means that this would not be valid then. And as you guys remember, we have to have both the opening and closing for this to be considered valid. So that's why we can just return false if the stack is empty. Okay, and then let's go ahead and do another else statement. Now here, I'm going to take a look at the top element of the stack, which we can do using the peek method. It's not going to remove or add anything, it's just going to get the top element. And now we can check if ch is equal to, now we want to check if it's closing or not. And checking if the top is equal to the opening version. Oh, sorry, this should be, yeah, this should be this, and this should be the opening right there. Okay. And or we can do same thing for the other ones. Just checking if it's CH is on closing. And then the top is equal to the opening. Okay, and then we do an or. We'll do the closing for that. And then top for the opening of that. Okay. Then we can go ahead and do a pop, which will take the top item off the stack. And then we can just do a continue. So what we're doing right here is we are on a condition where we are on a closing character. And our stack is not empty, which means that there is another character in the stack, presumably. And so we're checking to see if the top element is something that we can match. So if we have a closing and the top element is a right here, the corresponding opening for any of these combinations, then we can just pop that top one off and then continue. There will be no problems there. That would be right. So then there's another else scenario, which is going to be case 1, where the opening parentheses, opening closing parentheses or braces or bracket count, they're equal but they're mismatched. So we can just return false then, which is the condition here, if we get to this else. Okay. So now we can go ahead and check if the stack is empty right now. And if it is, then return true, because that would mean that we found a corresponding combination for every string or every character that was in the stack. Actually, we can just simplify this statement right here. We can just return is empty. And so if this is false, then that would take care of the second case, where the opening bracket count is greater than the closing bracket count. So let's go and see if this runs. Might have a syntax error somewhere, but oh, nope. All right, there you go. 1 millisecond passed. So time complexity for this is order of n, where n is the size of the given string. And then the space complexity is also order of n, where n is the space that we use for our stack right here. Okay. Let's see. Okay, so let me go ahead and show you guys a slightly different solution using the, right here, the array DQ. More complete and consistent set of LIFO stack operations provided by the DQ interface. Right here. It's a linear collection that supports insertion and removal at both ends. DQ is just short for double-ended Q. It's mostly pronounced deck. Okay, we have fixed limits on the number of elements. So here we have a lot of methods we can use as well right here. So with our DQ, it's a double-ended, so we can either let me just do this. So here we can add or remove elements from either end of the queue right here with our DQ. And we can do it like this. So this is kind of like a stack, but provides a little bit more functionality for us. So let me go ahead and just comment all this out. And let's go ahead and do a solution that uses that. So I'm actually going to use kind of a helper method for this solution. So let me do a boolean called isMatching, where we're passing in a char, two chars, let's call them A and B. We're going to return, so if A is equal to, actually, we can just copy this right here. It's doing the same check, but just putting in a different method. It's a little bit cleaner instead of having it in the main solution like this. And then CH is A, the top is B. Okay. Let's see here, make sure I'm not forgetting anything. Yeah, actually, I can go ahead and reverse these. It might be a little bit more intuitive to look at. Instead of having the closing first, it might make more sense to have the closing come later. Just a little bit better for readability. Okay. So we're just returning that. Alright, and so now let's go ahead and create our DQ. Still going to be using characters. Okay, so now we want to traverse the string. We'll do a regular for loop this time, instead of for each. Okay, so now let's go ahead and get our current character, keep a track of what it is, and then we can check what it is. If it is any one of these opening ones, oops. there we go. If it's any one of those opening characters, then similarly we can just push it onto the stack like we did before. Otherwise, first we can check if the list is empty or if it contains a closing character. So same logic as above. Then we can do an else if right here. So let's go ahead and call our isMatching method, and we want to have one of the characters be the top of our stack or DQ right here. So we can just use peak, and then we can do X, which is our current character that we're on, and we want to check if this is equal to false. And if so, we can return false. Otherwise, we could just pop. There'll be no difference there. Okay. And then now we can do return st dot is empty. And this is going to check if at the end of the stack is empty, or if it's not, a balanced string like this with a valid amount, same amounts. So let's go ahead and try submitting this. Okay, there you go. That also works using the DQ. Okay, so now let me go ahead and go over Python solution now, and we can go ahead and there's going to be two solutions for this as well that I'll go over. So the Python implementation for this is just going to be list, which functions kind of like a stack. So let's see. First, we want to go through those characters in a string. Check if char in. So this is kind of a shorthand way we can do this. We can just put all of those. So if the current character we're on is any of these right here, that's basically what this is doing. It's a nice short way to do that. Then we can just append. This is the same as pushing onto the stack. Let's go ahead and do an elif. Char is closing parenthesis. First, let's go ahead and check if not t or the last element of t does not equal the corresponding opening character right here. If this is the case, we can return false. And then if we did that, we can do a pop if that doesn't go through. If that doesn't execute, rather, then we can do elif char is, actually let me see here, might be able to just copy this and change it for each of the strings, or each of the characters. Let me just go and space this out. And let me go ahead and do this. Similarly for right here. Oops. Yeah, right there. And then this. Let's see here. Am I missing anything? Looks good to me. We can do if not t, return true. Otherwise, we can just return false. Actually, we can just simplify this to return not t. That should work. And calling not on the list right here is basically just checking if it's empty or not. So you can see this is pretty similar to what we were doing before. If it's one of the openings, then we can just append it onto our list. And if it's closing, then we check if it's the list is empty or not. Or if the last element, which would be our of the list, which would be equivalent to the top of the stack, doesn't equal the corresponding character, then we would return false. Otherwise, we could just pop off. So let's go ahead and run this. Okay, that worked. So now let me go ahead and show you guys it's a shorter solution. It's a little bit less confusing, a little bit more intuitive. So let's go and call our list stacks this time. This is going to be this. And this is going to be using a dictionary in this solution. So we want to map this to, we'll go ahead and put some spaces around here so it's not as confusing to look at. Now we're going to map it to that. Then we want to do the same thing for the other ones. We want to map each of the closing characters to their corresponding opening characters. Whoops. Just this. Put the parenthesis right here. Okay. So we have our map right here, or our dictionary, I mean. And let's call this opening bracket. And we're going to use a set right here. Within the set, we can do each of the opening characters. Okay, so now we have a set of those. So now let's go ahead and do for I and S. Loop through that string. If I is in the opening brackets, if it's contained in that, then we can just append that character onto there. Otherwise, let's check stacks is not empty, and stacks last element, which can be denoted with -1, is equal to current character, which case we could just pop. This is called stacks, not stack. Else, we can return false. Then outside of this, we can do stacks, which checks if the list has something in it. Return false. Actually, we can just do return stacks again. That should work. Let's see here. I forgot the colon on the end. see. If not stacks is what this should be. Actually, return not stacks. Let's try that. There we go. Okay, so you guys can see that there's a lot shorter in this solution. You're not having quite as many if-else checks. You're just putting characters into like a dictionary like this or a set like this. And just checking if it's within this, if it contains this. And then we're just going about it that way. So that's a pretty nice solution right there, only a few lines. Okay, so let's see here. I think we can do a C++ solution now. Yeah, let's go ahead and do one of those. So this is also going to use the stack. It's just done a little bit differently in terms of syntax. So we're just going to get the size right here of the string. Then we can get a stack. We're going to do it with ints this time. And we can use auto to initialize our I variable. Okay, and doing those same checks again. If it's open or equal to any of those opening characters. Let's go ahead and just copy this. Okay, so if that's the case, we can push I on. And you can see that instead of using characters, it's using int, but it's pretty much equivalent because every ASCII character is mapped to an integer value, so, or an int value rather. So that mapping is perfectly fine to use right here. So let's go ahead and check if the current is a closed bracket. If no open bracket to match the current closed bracket, you can just return false. And then also check if I is equal to that, and same as before, we're checking if top is equal to the corresponding opening. Go ahead and do this once, twice. Do that. Okay, there you go. And if this is true, then we want to not return, we want to pop. Otherwise, we can return false. Okay, and now we can just turn empty. Let's see here, let me make sure. Okay, actually this should go outside the loop. I feel like there's a parenthesis out of place right here, but let's just see. Oh no, it's fine. Okay, so there's that C++ solution, pretty similar to the Java one. And with that, I think that does it for this video. So we went over the valid parenthesis problem, another type of string problem, which involved using the stack as the main data structure for this problem. I hope you guys learned something. Thank you for watching, and I will see you guys in the next video that I make for this series. Take care. Bye.